Hello, everybody. How are you? Nice to meet all of you. Welcome to Mr. Chu's online lesson. Uh, with that initiation, shall we begin? Okay, so I'm going to put on the screen right now. Okay, here's the thing. I hope that throughout this one, if you have anything you want to share, then just let me know lah. Okay. Uh, Hello, everyone. Everyone, hello. So we are going to talk about the technique of answering Stpm chemistry for semester one for year 2023. Hello, everyone. Nice to meet all of you. Okay. With that session, let's begin, shall we? Okay. To those who don't know me, I would like to introduce myself. My name is Mr. Chu, Chu Chin Quen. I'm currently 42 years old. I was origin from Pontian, Johor, currently teaching in SMK Tasik Utara, Johor Bahru. I've been teaching Stpm chemistry since 2003 until 2023. So hopefully with my 20 years of experience, I'll be able to help you all to understand better about how to answer Stpm chemistry. Okay, this photo was taken last year during the Ironman Langkawi. So also Ironman finisher. Okay. Yes, you. Can this review? Yes, it can be viewed later. Don't worry. It is automatically saved on YouTube. Okay. Okay. So shall we continue? Okay. What are my experiences? I've been teaching since 2003 until now. I have 20 years of teaching experience. I'm an ex-national trainer for Stpm chemistry for Malaysia. However, I already quit this since 2017 due to personal reason. Okay. To those who know me, you know the reason. Okay. I also presents the technique of how to answering in various states across Malaysia. Of course, in Johor included. Okay. And also a YouTuber. YouTuber in the sense of Stpm chemistry, not all these music things or whatsoever. Okay, so if you already know me, this is my channel, Chu Sensei's channel. So if you already bought my books through Shopee, then you probably see the technique how do you study semester one. Okay, so these are the books that I've written previously. Okay, so I don't know whether you still have this exercise from the LP production, but I already stopped them from publication it already. So the most recent book that I have is this one, Absolute Guide of Stpm Chemistry. So I use this book nowadays as my major references. Okay, so please support original. Don't photocopy. Okay. So this is it. So shall we begin? Okay. So I'm going to introduce to you the format of Stpm. So Stpm's examination papers is made of 3 sections. So section A, section B, and section C. So section A is 15 compulsory multiple choice question to be answered. And then you have 15 marks, one objective answer, 1 mark. And then you have section B, which is 2 compulsory structure question to be answered. 1 8 marks, 1 7 marks. Okay. So also 15 marks. And then you also have section C, which are 2 questions to be answered out of 3 essay questions. So all questions are based on topic chapter 1 to chapter 6. So the weightage is 30 marks. That means 1 essay is 15 marks. Okay, so here is the thing. So if you count carefully, 3 essay, right? 15 mark on objective, 15 mark on structure, 15 mark on 1 essay, 15 mark on second essay. So do you see that section A, section B, and 2 of the question of the section C share the same mark weightage, isn't it? So what am I trying to tell you in here is, do not over focus only on one section. Okay, so if possible, distribute your section equally in time. So for example, objective 20 minutes, structure 20 minutes, one essay 24, 25 minutes, another essay 24, 25 minutes, because you got a lot of things to write. So you must time yourself, okay, effectively, in order for you to learn on how to answer, okay. Okay, so you have 3 semesters. Each semester weightage is 26.67%. So you have paper 1, paper 2, and paper 3, sem 1, sem 2, and sem 3. And then you have school-based assessment, which is 20%. So that makes out of total of 100%. So usually the 20% your school teacher will help you to get as high mark as possible. So please do your practical well. So please do not underestimate the power of 20%. So please try. Okay. Okay. So so shall we begin our talks for today? Okay. So I'm not going to talk a lot on the syllabus content. I'm more to focusing on the question, because I suppose that if you already know the things, you should have been very well versed in the in semester 1. Okay. So shall we? Okay. Okay. So I'm going to this one for a while. Yeah. Now, can you all see this one? Any problem so far? Hopefully no. Okay. Okay. So shall we? Okay. So we are going to go to the technique of how to answer Stpm semester 1. Okay. So I've already shared the question paper through various channels. I've already shared in Telegram. Mostly it's Telegram for now. So only through Telegram channel your teachers can effectively share with you. I also put in all the questions, answer, everything's there. So if you later you miss out, inside my YouTube introductions also I attach the box link so that you can feel free to download. Okay, so this presentation is not pay-per-view. You don't have to pay anything to watch this presentation. So don't worry, I won't collect a cent from you. So this is like voluntary works for all of you. Hopefully you all will be able to benefit from it. Okay. Okay, so without annexation, shall we begin? Okay, so because of the time constraint, I will go a little bit fast. And if you have any questions, please type in the comment and I will try my best to answer you as much as I can. Okay. Okay, so shall we? Okay, so let's go to number 1. Skin cancer can be treated using a radioactive isotope phosphorus 3215. A compound contain phosphide ion P3215 P3- wrapped in a plastic sheet is strapped into the affected area. What is the composition of the phosphide ion? So from the formula 3215 P3-, so you should know by yourself that in 3215 P3-, number of proton is 15. So number of neutron is 32 minus 15, which is 17. Now P3- means that you have accepted 3 electron. Okay, you have accepted 3 electron. So 15 plus 3, which give your final answer is equals to 18. So this will make your answer to be A. Okay, well done, very good. Okay, so this is how you answer for section 1. So you must be well versed to how to calculate all this. Okay, is my voice loud and clear enough for you all to hear? If my voice is too soft, do let me know, because I don't know what is going on there. Okay. Okay. So that is for question number 1. Okay. So shall we move on to question number 2? Okay. So question number 2, which statement about 3p orbital is correct? So now we are talking about 3p orbitals only. Okay, 3p, specifically 3p. So A, it can hold a maximum of 6 electrons. So according to Pauli exclusion principle, each orbitals can hold a maximum of 2 electrons. 3p has 3 orbital, so 3 times 2, that will equals to 6. Okay, so that is why A is true. Okay, as for B, it has the highest energy orbit of the orbital with principal quantum number n equals to 3. Is 3p the highest energy levels for third shell? No, there is a higher energy level, which is 3D. Okay, 3D. So number 2 is wrong. 3D has a higher energy level. Okay, number C, it is at a higher energy level than 3s orbital, but it has the same shape. No, S orbital is a spherical shape, okay, but P orbital is a dumbbell shape, okay. So S orbital is a spherical shape, P orbital is a dumbbell shape, so C is wrong. And then D, it occupies 2 electrons in an isolated sulfur atom. What does it mean? It's occupied by 2 electrons in an isolated sulfur atoms. So it occupies 2 at the isolated sulfur, which is wrong, because if the electronic configuration of the sulfur is 3s2, okay, and 3p4 lah. So when you have 3s2, 3p4, so the p orbitals of the 3p4 will look like this. I'm drawing using mouse, so if it is not nice, please bear with it. But I hope that you understand what I try to draw in here. Okay. Okay. Okay, so this is the answer. So the best answer in here is A lah. Okay. Okay, so can you all hear me or not? Because I see this Go Sheng Wen, hello, hello, hello. Testing 1, 2, 3. Can you all hear me or not? I don't. If I lost, can you let me know? Because I'm not sure if I really lost the signal. I cannot see here. I can only see you all like this only. Okay. Yes, I can. Okay. Okay, 4 electronic configurations are shown below. 3 of these electronic configurations belongs to an atom of the element chlorine, copper, and magnesium. Which configuration belongs to an atom of another element? Okay, so you have to know by yourself. Chlorine has magnesium has the electronic configuration of 1s2, 2s2, 2p6. Thank you very much for response. And then silicon is 1s2, 2s2, 2p6, 3s2, 3p4. And then C is 1s2, 2s2, 2p6, 3s2, 3p5, which is chlorine. So the one that is not, belongs to another element is donkey D lah. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1 is belongs to copper. So the answer is donkey D, not B. The answer is donkey D. I wrongly highlighted. Can you help me to adjust the this one? Sorry. I wrongly put in the highlighter. If the answer there is also wrong, can you help me to this one? Okay, so hopefully it's okay. Okay, so I wrongly highlighted. Sorry for that. But the answer is donkey D. Okay. Okay. Hello, Victor. Okay, so with that, that is for number 3. Okay, any questions so far? Which part in here you cannot understand would like me to repeat for you? Of another atom, answer correct. Answer correct. Not the answer is donkey D. Okay, answer is donkey D. Okay. If I type wrongly so you hopefully you'll be able to help me to correct it. The answer is donkey D. Okay. Okay, number 4, sodium hydrogen sulfide, NaSH, is used to remove hair from animal hides. Which statement is not true about SH minus? Okay, so now in order to understand the structure of the SH minus, you draw this one. Okay. So so this is the structure of the HS. Okay. Sorry. Can I go back? Chlorine, copper, magnesium. Oh, okay, the answer is B. The answer is B. The other element is silicon. What am I thinking? Sorry, I confused this one. Sorry. Answer just now is B, correct? Sorry, the answer just now is B, correct? I mistaken it for something else. Sorry. Answer is B. Okay, B. Answer is B. Sorry. Okay. I also confused a while. You know, old man. Okay, so okay, back to number 4. Okay, so this is the Lewis structure of the HS minus. HS minus. So in the HS minus, the formal charge is on the hydrogen atom, which is wrong. Actually, what is formal charge? Formal charge is the charge possessed by the particular atoms. Basically, formal charge is slightly already a little bit out of syllabus, but I was hoping that you'll be able to look into by yourself, and I can see that some of the school teaches you how to calculate formal charge. Okay. So you have to slightly learn on how to calculate formal charge, because nowadays in Stpm, when you are asked to draw the Lewis structure, they require you to put the charge on the atoms that is responsible to hold the charge. Okay, so you can only calculate via the formal charge in here. So about how to calculate formal charge, I can only roughly guide you on how to calculate formal charge. So the formal charge, we said the Fc is equals to total of the valence electron. Okay, total of the valence electron minus of the this half of the bond pair electron. Okay. Sorry, I'm using mouse to write, so I may be a little bit slow. Okay, plus the total of the total of unbound electron. Okay, unbound electron. Okay, so this is how we calculate the formal charge in here. Okay, so in the case of the hydrogen, hydrogen is 1 valence electron minus of half times 2, because lone pair electron, bond pair electron is 2 electron, isn't it? Okay, and then you see that hydrogen does not have any single electron, so minus 0, so you get equals to 0 lah. So the formal charge of the hydrogen is 0, whereas the formal charge of sulfur, valence electron of sulfur is 6. Okay, valence electron of sulfur is 6. You minus off half of the bond pair electron, which is 2. Okay, minus off the unbonded electron. So the unbonded electron in here is 6. You can see that there are 6 electrons. So total of the formal charge in here is equals to -1. So that is why we say that this negative belongs to the sulfur in here. Okay. So this is basically how you calculate the formal charge in here. Okay. Okay, so therefore, formal charge is located on the sulfur atom. So A is wrong. 3 lone pair electrons surrounding the sulfur atom, which is true. And then single covalent bond between H and S, which is also true. And then total valence electron is 8. So total valence electron, as you can see here, is 8, which is true. So the best answer in here is A. Okay. Okay, so this is how we are going to answer for question number 4. Okay, any questions so far? Thank you very much. You know, sometimes old men sometimes make mistake. Actually, the answer just now is correct already. So this one. Okay. So that is for how you are solving for number 4. Okay, any questions so far? Okay, so hopefully no question. So we goes to number 5, shall we? Okay. Number 5, which element shows the greatest tendency to form covalent compound? Question number 4, some of you ask why the valence electron, some of you ask, teacher, why the valence electron is 8? In here, valence electron is 8, as you can see. There you have 8 electron. Total valence electron in here. you have this is 2, 4, 6, 8. Hydrogen don't have ma, see that or not? Hydrogen don't have ma, see that or not? So total 8 valence electron. Okay. Okay. So this is why. Okay, so can we continue to the next one? Okay. So which element show the greatest tendency to form covalent compound? So in here, covalent characteristic which has something to do with the polarizing power So we say is that polarizing power is directly proportional to the charge density Sorry, I'm using mouse to write, so I may be a little bit handicapped. Okay, it's directly proportional to the charge, yet inversely proportional to the ionic radius. Okay, so as you can see in here, aluminium has the greatest. Aluminium here has the greatest charge. And the smallest ionic radius. Therefore, aluminium has the highest charge density. So when aluminium has the highest charge density, therefore among these 4 elements, it has this greatest tendency to form this one. William, if you want to look back, I think I attached the answer, isn't it? You can find. If you look at the YouTube channel there, you see the description. Under the description, I also attached the answer scheme, isn't it? You can download from there. Okay. So today you come here just to focus on listening the talk only. So you don't need to copy anything. It is exactly the same. All right. Okay. Number 6. Which of the following is when liquid form there only intermolecular forces based on temporary dipole between particles. So temporary dipoles are non-polar molecule. So to understand what is the forces that is hold in between them, so I purposely draw out the Lewis structure for all of these molecules. So you have ethanol, water, bromine, and hydrogen chloride. So as you can see in here, inside ethanol, it is held by the hydrogen bond. Okay, so water is also held by hydrogen bond. Bromine being a non-polar molecule, so it is held by temporary dipole, or sometimes we say induced dipole. Okay. Okay, and then finally we have a hydrogen chloride. So hydrogen chloride is a dipole molecule. So dipole molecule means that it is going to be a polar molecule. Sorry, polar molecule. That means it has a permanent dipole. Okay, it has a permanent dipole. So in here, which of these only have the intermolecular forces if temporary dipole is C, bromine. Okay. Okay, so some maybe throughout the discussion, because inside the answer scheme, I didn't really draw out the structure. I only draw out inside the slide. So in case you miss it, you might want to screenshot on your own through the YouTube, and then you later revise on your own. Okay, or if you accidentally miss that, you can always revisit through the YouTubes. This presentation will always be permanently inside the YouTube, so don't worry about it. Okay. Okay, so that is for number 6. So the answer is C. Okay, number 7. In an experiment, a sample, what is it, polar, non-polar? We say is that how to differentiate. Okay, wait. Okay. So teacher, how to differentiate between temporary dipole and permanent dipole? Temporary dipole is for polar molecule. So if to study what is a polar and non-polar molecule, you have to go back to when we discuss about the polarity. Of course, I don't discuss in here right now, but you have to know by yourself that in such molecule, okay, you have to know that like this one, because it has the same electronegativity, okay? Okay, you have the same electronegativity. So therefore, this is a non-polar, but this one, you have this is 2.1 ma. This one electronegativity is 3.5 ma. So the polarity, the magnitude will point towards the direction of the hydrogen. So therefore, we say that HCl is a polar molecule. Okay. So I hope that I clearly explain this one. Okay. Okay. So shall we go back? Okay. So this is for number 6. Okay, then number 7, in an experiment, a sample of the pure gas is put into a gas range at the temperature 300 Kelvin, while the pressure is 16 kilopascal. The gas is compressed until the volume occupied by the gas half. Okay, so the volume is half. After compression, temperature of the gas range is 375 Kelvin and the pressure is 40 kilopascal. Which statement is true? Okay, so in order to understand whether this molecule is polar or not, is ideal or non-ideal, so it will fulfill the ideal behavior where you have P1V1 over T1 equals to P2V2 over T2. So let T1 equals to 300 Kelvin, P1 equals to 16 kilopascal, T2 is 375 Kelvin, and P1 is 40 kilopascal. So if you use the formula P1V1 over T1 equals to P2V2 over T2, okay, so as you can see in here, when the intermolecular, as you can see in here, when you have double, you see now volume occupied by gas is half. That means at your current situation, the volume becomes half of it. So that means volume 1 is equals to 2 times of the volume 2 because half times half, correct or not? So it obeys the ideal gas law. Therefore, it is an ideal gas. Okay, understand or not? What am I trying to say in here? Okay, if you look at the question carefully, the question said that the volume is half. So V1 is equals to 2 times half of the V1. Okay, do you see? Do you understand? So that is why we say that it obeys the ideal gas law. Okay, so it shall have all the characteristics of the ideal gas. So for example, A, intermolecular forces of gas are significant. Wrong. When it is a non-ideal gas, so it is insignificant. Okay, and then it is possible to calculate the number of mole of gas using the present data, which is also false because we don't have the sufficient values in here. Number 3, the gas obeys the ideal gas law, which is true, and the pressure used are too high for ideal behavior. Actually, 16 kilopascal, 40 kilopascal is not high pressure. Our normal atmospheric pressure is already 101 kilopascal, isn't it? So these are considered low pressure. Okay, so the best answer in here is C. The gas obeys the ideal gas law. Okay. Okay. Okay, so this is for number 7. Okay. Okay, so any questions so far? Yeah, so if no questions, then let's continue to question number 8, shall we? Are you okay with no background music or anything? Because I'm afraid that if you have background music, it will disturb the talks. So I better don't put any music, isn't it? Okay. Mr. Chu class never put any music one, very boring one. That's why probably because of that, nobody want to really follow. Okay, whatever. So number 8, ethane 1,2-diol is used as antifreeze. It allows ice melt at temperature below 0 degrees Celsius. Which statement best explain this property? So in here, why does this ethane 1,2-diol act as an antifreeze? Antifreeze means that it prevents water from freezing. So how does it prevent water on freezing? So now, if you want to know, so this is how the ethane 1,2-diol looks like. So I'm going to draw it. Okay, so ethane 1,2-diol is CH2. Okay, CH2. Okay, so this is OH and OH. So you can see it easily form hydrogen bond with the water. Okay. So when it easily form hydrogen bond with the water, so that is how it is going to interact with the water. And once water is held together by this hydrogen bond comes from the ethane 1,2 diol, so it will have stronger intermolecular forces. So when you have stronger intermolecular forces, it somehow helps to it somehow makes the intermolecular forces become stronger. So when the intermolecular forces now become stronger, so that is why the melting point eventually will become decrease, isn't it? So this is how you reduce. And furthermore, ethane 1,2 diol also occupy the surface of water. What does it mean by occupy surface of water? Now let's together imagine these circumstances. If let's say this is, if let's say you have a, if let's say you have a vessel looking like this, sorry, because I use this drawing, not very good. Okay, so this is the, let's say this is for pure water. Okay, so you have pure water inside here, all of them are pure water inside here. Okay, so now this is surface occupied by only pure water. Okay, but suddenly you have ethane 1,2 diol, which I highlight with red color. So when you have ethane 1,2 diol, it somehow occupied the surface of water. So when you occupy the surface of water, it prevents the surface to easily absorb the heat from the surrounding. So when it disturbs the heat from the surrounding is being absorbed, because to melt you require heat, correct? So that is why it will disturb the extension of the network in the hydrogen bond inside the ice, therefore reduce the pressures in here. Okay, so I know it's a little bit difficult, but that's why I try my best to use more diagram. Oh, sorry. I try my best to use more diagrams to help you to understand this one. So actually, number A is correct. It form an number A is wrong. It does not form insulating layer. B is correct because it disrupts the extensive network of hydrogen bond inside the ice. So C is also correct. It forms hydrogen bonds. Ethane 1,2 diol molecule form hydrogen bond with other ethane 1,2 diol molecule. This statement is correct, but it does not explain why it lower the melting point of the ice. Okay, but if the C selection says that ethane 1,2 diol molecule form hydrogen bond with other water molecule, yes. It actually try to explain it disrupt the extensive network of the hydrogen bond in ice. Okay, so that is why it is incorrect for C. Then for D, ethane 1,2 diol molecule dissolve in water. Yes, it does dissolve in water, but now this is when it dissolve the water is the initial factor. It dissolve in water by forming hydrogen bond. Therefore, as a conclusion, it disturbs the extensive network of the hydrogen bond in ice, therefore lower the melting point of the ice. Okay, so that is what the whole thing is all about. Okay. Okay, so I'm not sure whether you understand what am I trying to explain, but at the end of the day, what I try to explain here is when you add, when we call it as a non-volatile solute. When we add a non-volatile solute inside a solvent, it will reduce the melting point of the substance by disturbing the crystalline structure inside the substance itself. Okay, so for more information, you can read up on the non-volatile solute inside the water there. Okay, okay, so that is for number 8. Okay, so immediately we goes to question number 9. Oh, by the way, any question on number 8? Okay, so if no questions, you feel free to type, then I will post your comments on the screen so that everybody know what you are asking. Okay. Okay, number 9. Boltzmann distribution graph shows a fixed amount of gas at 2 different temperatures. So this is the Maxwell-Boltzmann distribution graph. So which statement is correct describing the feature of this diagram? Number 1, temperature T1 is lower than T2. Do you agree? Yes, okay, so T1 is lower than that of T2 since the peak in T1 is higher and more left than T2. Okay, so temperature T1 lower than T2. Correct. One is correct. One is correct. Sorry. One is correct. One is correct. Can you help me to correct this statement? One is correct. It's true. True. Temperature T1 is lower than T2, which is true. Not false. True. Okay. Okay. And then, so this is for T1. Okay, and then number 2, the shaded area indicates particles have sufficient energy to react at T2. So not only at T2, so it is actually T2 and T1. Okay, T2 and T1. So this statement is actually false. Can I? And T1, T2 and T1. Sorry because sometimes I might accidentally type wrongly in here. The shaded area indicates that particles have sufficient energy to react at T2 and T1. Okay, and T1. So this is false. My bad because I didn't see clearly the answer. Okay. Okay. Then number 3, the total area under each curve is the same for both temperature. Okay, so actually true. So total area are the same for here. And then finally, the peak of the curve will shift to the right as temperature increase. Now, it is not the peak of the curve will shift to the right. The peak of the curve will shift to the right as temperature increase. The peak of the curve shift to the right as temperature increase. And this one also true. The peak of curve will shift to the right when temperature. Therefore, statement 2 is wrong. Statement 4 is wrong. Okay. Okay. So therefore, the answer in here is 1 correct, 3 correct. So there is no answer in here. I apologize for the mistakes made in these questions. Okay. So can I correct it and then later you print screen. You print screen. Okay, I apologize for this one. So T1 is lower than T2 since T1 is higher and more left. Okay, and then and T1. So this is false. Okay, sorry for that. I made some mistake in here. So I hope that you all will be able to help me to correct. Okay. So the answer is 1 and 3 not 2 and 3, 1 and 3. So in this case, there are no answer for these questions. I apologize for, yes, statement 1 is correct. Yes, statement 1 is correct. Okay. Sorry, I apologize for the mistake caused in here. So it's 1 and 3, not 2 and 3. 1 and 3. Okay. Okay. So sorry for that. Okay. So let's continue to number 10. Okay. Crotonaldehyde CH3CHCHCOHO can be obtained by oxidizing butadiene using air or oxygen. One method is to pass by the mixture of butadiene and oxygen through hot solution of palladium 2 ion, which catalyze the reactions. Yeah, typo, typo, yes. Yes, T1 is lower than T2. Yes, you're right. That's why I said that I made mistake in here. So please help me to correct. The answer is 1 and 3, which inside the ABCD selection, there is no answer. Okay, sorry for that. Okay, and then which statement is not true about the action of palladium 2+? So changing the concentration of PD2+ will have a slight effect on the rate of reaction. So A is considered true. Okay. However, adding too much also not helpful at all for catalyzing the reaction. That is why catalysts will only use a small amount only. Okay. Okay, so number 2, PD2 plus increase the energy. So adding PD2 plus does not increase the energy of reacting molecule. No, it actually lower the activation energy by providing alternative path. So B is false, C is true, D is also true. Okay, so which will give our answer for the reactions in here is B. Okay. Okay, so that is how are we going to explain the effects in here lah. Okay. Okay, so that is for number 10. Okay, any questions so far from number 6 until number 10? If you need me to repeat any place in here, I'll be glad to do so. Okay, so if no problem, then we goes to number 11, shall we? Any questions? Feel free to ask if you have any. Don't feel shy. I'm okay. Okay, so no problem. Then immediately we goes to question number 11. So question number 11 sounds like this. So nitrogen react with hydrogen to produce ammonia according to the equation. A mixture of 2.00 mole of nitrogen. Teacher, can you explain again? Sorry, I only saw this just now. Teacher, can you explain why is B incorrect? B, okay. Adding catalyst does not increase the energy. Energy of the reacting molecule can only increase by increasing temperature. Okay, increasing temperature. Okay, okay. Then some of you ask question number 8. Okay, so can I go on to back to number 8? Okay, so in number 8, I already delete the diagram already. Why question number 8? Number 7 is it? Number 7. Number 7. Okay, number 7 just now, 7, not 8. Number 7, it is ideal gas because they said that half of the volumes in here, okay? Half of the volume in here, because after the calculation, you can, the question says like this, Now, sometimes English is also quite important. You must understand what is going on. So when gas is half, so that means V2 is half V1. Understand or not? So when you move this 2 to here, so V1 is equals to 2V2. See that or not? So that is why V1 is equals to 2V2. Therefore, it is ideal gas. Okay. Okay. So that's what I can tell you. Okay. And then can I go back to the comment? Okay. Teacher, number 9. How to know T2 is higher than T1? That not depend on peak. T2 is higher than T1 in here. Can I go to this one? Okay, T2 higher than T1 in here. If the peak become lower, you have to remember the 3 significant things inside here. As temperature increase, okay, as temperature increase, peak become lower. Peak become lower indicates that lesser particles travel at average speed. Okay, then the base of the peak become broader. The base of the peak become broader. I highlight. Okay, you see that the base of the peak become broader. So this is the peak for T2. Okay, become broader compared to the peak of the T1. So this is the base peak of the T1. So I use blue color. Okay, so you can see that the area in the yellow is greater than the area in the blue. What does it indicate? That means it indicates that more particles has energy greater than the activation energy. So therefore increase the rate of reactions. And then finally, the peak shift to the right. So when the peak shift to the right, it indicates that even for average, molecule travel at average speed can move faster. Okay. So that is why you have this one. Okay. So I hope that I answer to your questions in here. Ching, you know that you can ask me in school. Okay. Okay, so this is for number 9. Okay, number 10. Okay, then we go for number 11. Okay, so we continue from here. So for question 1, why statement 2 is wrong? Statement 2 is wrong because T1, if do you see the explanation just now or not? Greater the shaded area indicates particles have sufficient energy to react. So in here, the shaded area, you look at the selection, the selection says that the shaded area indicates particles has sufficient energy to react at T2. So the shaded area indicates particle has sufficient energy to react not only at T2 but also T1. It's just that the area of the T2 is greater than the area of T1. That's all. But actually, statement number 2 is not complete. So that is why we said statement number 2 is false. Okay. Okay. Can Okay, so back to the questions already. Okay, so a mixture of 2.0 mole of nitrogen, 6.00 mole of hydrogen, and 2.40 mole of ammonia is allowed to react to reach equilibrium in a sealed vessel of 1 decimeter cube under certain conditions. It was found out that 2.32 mole of nitrogen were present in the equilibrium. What is the value of Kc under this condition? So at the end of the equilibrium, the amount of the nitrogen is 2.32. Okay. The amount of, you see, from 2 increase to 2.32. That means somehow in some way, equilibrium shift to the left. Okay, equilibrium shift to the left somehow. So that is why if in here, stoichiometrically, 1 nitrogen react with 3 hydrogen to form 2 ammonia, since the nitrogen increased from 2 to 2.32, it increased by 0.32. So when we say increase by 0.32, that means hydrogen also increased by 0.32 times 3, because stoichiometrically 1 to 3. So you plus 0.96. At the same time, because reactant, a product form reactant, if reactant increase, that means the product decrease. Therefore, minus 0.64. This 0.64 is a result of 2 times 0.32. Okay. So you get 0.64 So it's minus for that. Okay. Okay. So therefore at equilibrium you can start to apply Kc So 1.76 divide by 1 Sorry for that. I supposedly I write divide by 1 Okay. Supposedly I write divide by 1 divide by 1. Everything divide by 1 Okay, my bad. I didn't write divide by 1 inside my solution. Okay, so then you press your calculator, you get 3.96 times 10 power of 3 mole minus 2 dm6 in here. Okay. Okay, so that is for number 11. Okay. Any questions? Sir, can you explain again shift to left? No, shift, because you see initial you have 2.0. It was found out that 2.32 were present at the equilibrium. See that or not? So from 2 increase to 2.32, that means equilibrium shift to the left. Okay, that is what it means. Try to say in here. Okay. Why shift to the left? Because of certain factor. There may be a lot of factor. In decreasing pressure can, concentration of the ammonia increase also can. It doesn't say what factor. You don't go and bother why shift to the left. All you need to know is when reactant increase, that means equilibrium shift to the left. Okay. Now, in Stpm, don't think too much. You think too much, at the end, you trouble yourself. Straight away, go to the question. Okay, don't think why must shift to the left? Why cannot shift to the right? It shift anywhere it wants. Okay. Okay. No, I mean, apply on certain condition, it shift to the positions it want. Okay. Okay. Okay, number 12. In the contact process for the production of sulfuric acid, sulfur dioxide is mixed with air and passed over vanadium oxide as catalyst at 450 degrees Celsius and a pressure of 1 atmosphere. So what affects the choice of the condition for the reactions in here? A. Let's together look at the solutions. A lower temperature would not raise concentration of SO3. So when you lower the temperature, it causes equilibrium shift to the right. Why equilibrium shift to the right? Since equilibrium forward reaction is exothermic. So when the forward reaction is exothermic, therefore equilibrium shift to the right, concentration of SO3 increase. Okay. Okay, B. Use of vanadium oxide only increase the rate of oxidation, which is true because the uses of the vanadium oxide as a catalyst increase the rate of oxidation. Rate of oxidation is SO2 react with oxygen. Okay, hence increase the rate of reaction, which is also true. Okay, and then number 3. Increasing the volume of the reaction vessel will increase the yield of SO3, which is false because increasing the volume of the reaction vessel will cause the pressure to decrease. Hence, equilibrium shift to the position with more total mole of gas. Therefore, decrease the yield of SO3. Okay, so C is false. And then Kc of the reaction is the same with Kp. No, this one you use the Kc of the reaction is not the same of Kp since Kc is equals to Kp times RT delta N. So delta N is referring to total mole of reactant, total mole of product minus total mole of reactant. Okay, so total mole of product is 2 total mole of reactant is 3 so delta N is equals to -1. Therefore, Kc will not equals to Kp in here. So D is also wrong. Okay, so the best answer in here is boy B. Okay, so that is for number 12 lah. Okay, so can we move on to number 13? Okay. If you have any question, feel free to ask. You can always interrupt me. You know that I will help you as much as I can. But teacher, for question 11, if equilibrium shift to the left, isn't the reaction is reversed? No lah. The question already give you this equilibrium. Okay, use this equilibrium. Don't use this equation. Don't go and say that our equilibrium shift to the left, the reaction is reversed. No, the reaction is still ongoing. It's just that it shifts to the left. The reaction is still ongoing. It shifts slightly to the left only. Okay, that means it form more product. When we set a dynamic equilibrium, that means the reaction is still going on. Some reactant will form product. Some product will form back reactant. That's why we said reversible. So the reaction is still ongoing, just that it shifts to the left. That means now, under certain condition, it goes a little bit to the left only. But some of the reactant will still form product. Understand or not? So you have to understand the principle of dynamic equilibrium in this case. Okay, so no need to reverse the equation. No need to reverse the equation. Okay. I hope that I solved the I explained. Okay. So in which reaction is the underlying substance act as a base? Okay, so in here, how do you easily tell that it acts as an acid base? You have to understand the principle of Bronsted-Lowry acid and Bronsted-Lowry base. What is the Bronsted-Lowry acid? So Bronsted-Lowry acid is a proton donor. Okay, so when you say that it is a proton donor, that means it is a H+ donor lah. When you know that it is a H+ donor, that means the number of the H+ will decrease. Okay, the number of H+ will decrease. Okay, and then the Bronsted-Lowry base is terbalik. So for Bronsted-Lowry base, it is a H+ acceptor. Okay. So the number of the H+ will increase. So if you check from the reactant to the product in here, if you check from the reactant to product in here, okay, see what happened towards this one. Does the H+ increase or decrease? So you know that whether it's acid or base, correct? Okay. So therefore, in this case, HCO3 minus first accept H plus to form H2SO3, then decompose to become H2O. So that is why the answer is C lah. In A, you can see H2SO4 decrease. So donor lah. In B, you can see that H also decrease. Therefore, also donor lah. In D, you can see that H also decrease. So D is also acid law. And then finally C is first accept the H plus to form H2CO3, then decompose to become H2O and CO2. Okay. Teacher, wait, Teacher, question 12, option C, it says that increased volume, increased oxidation of SO3, right? Increasing volume of the pressure will decrease, increasing volume of the pressure, increase the oxidation of SO3, right? No, increasing the, can I erase your comment for a while? Increasing the pressure, increasing the volume will cause the pressure to decrease. When we cause the pressure to decrease, equilibrium will shift to the direction with more total mole of gas. So it will decrease the yield of SO3. Okay. Why? Isn't C correct too? C is false. Increasing volume of the vessel will increase the yield. No, it is decreasing the yield. Okay. Don't confuse. Okay. Screenshot and try to study what I type inside here. Screenshot, try to study what I type inside here. Okay. Okay, so that is 13. Okay, 14. Silver chloride is partially soluble in water. It's a saturated solution of AgCl. The concentration of the silver ion Ag plus at 298 Kelvin is 1.33 times 10 power negative 5 mole per decimeter cube. Which following statement is true? Can understand or not? Number 12. Can understand or not? Number 12. Am I scrolling too fast? You screenshot first and then you study. Okay. Can okay. Finish Okay. So okay. So in the concentration of the silver ion is 298 is 1.33 times 10 power negative 5. Which statement of the following is true? Okay. Increasing oxidation is the same as concentration of SO3 decrease? No lah. Hey, 单间相啊. You sure what you are talking about or not? Increasing oxidation of SO3 is the same as concentration of SO3 decrease? You need to increasing the volume of the reaction vessel will increase the yield. You are I become confused by you. I don't want to be confused by you already, Tan Jin Xiang. You need to understand the explanation first. Okay, sorry, I cannot stop too long for you. Okay, so the solubility of the silver chloride is 1.33 times 10 power. Solubility of the silver chloride is 1.33 times 10 power negative 10, which is false. So solubility is 1.33 times 10 power negative 5. That is X. Inside this case, you have silver chloride, correct or not? You have AgCl, dissociate to give Ag plus and Cl minus. Okay, so if this is X, then you form X and X. Okay, so X in here is referred to solubility. So the solubility is 1.33 times 10 power of negative 5, since the concentration of the silver ion is 1.33 times 10 power of negative 5. Okay, so solubility is times 10 power of negative 5. Huh? Okay, precipitate will form when saturated solution is heated. So precipitate falls because most of the time this process is endothermic for your information. For sparingly soluble salt, most of the time enthalpy change is endothermic. Okay. Okay, so if the enthalpy change is endothermic, increasing equilibrium will cause equilibrium shift to the right. Okay. So that is why precipitate, the solution will dissolve. Okay, C, the unit of the solubility product is mole cube, dm minus 9. False, is mole square, dm minus 6. And then D, precipitate will form after adding HCl into saturated HCl is true because of the common ion effect. So as a result, when concentration of the Cl minus increase, equilibrium shift to the left, you form more precipitate. So the answer is D. Okay. Okay, so that is for number 14. Okay. Okay, so can understand? Okay. In this case, solubility product is how many? I don't have calculator. Solubility product in here is 1.33 e negative 5 square. 1.77 times 10 power of negative 10, the solubility product KSP okay. Okay, so I hope that you'll be able to calculate okay. Okay, so that is all for number 14. Okay, and last but not least, number 15, the diagram below shows the boiling point composition curve diagram for a mixture of H2O and HNO3 constant pressure. What is the composition of the two liquid when 30% of the H2O is subjected to efficient fractional distillation? Okay, so now for your information, this is what we so called as a negative deviation. When we said you have a negative deviation, okay, when we say that you have a negative deviation, that means the vapor pressure is lower than expected. So if vapor pressure is lower, that means boiling point is higher. Boiling point of azeotrope is higher. So this is the azeotropic mixture in here. Okay, so this is the azeotropic mixture. It is higher than the pure water and also the pure nitric acid. Okay, so when 30% of the H2O, so where is 30% of H2O? If this is 100% of H2O, that means 30% is this one. Okay, 30% of H2O. Okay, so thank you very much, Angels, for helping me to explain. Okay, because sometimes I cannot focus. Those, if you understand the question, please help your friends around. Okay, okay. So you are going to start from 30% of water Okay, so vaporization, condensation, vaporization, condensation. Vaporization, condensation, vaporization, condensation. So the first distillate in here will be pure nitric acid. Okay, pure nitric acid will be the first distillate. And if the reaction is still continue on, if you have a second distillate, then the second distillate is definitely azeotropic mixture. Then the residue will be in pure. The residue will be in pure water. Okay, now you have to imagine something like this, class. When it comes to a positive and negative deviations in here, you have to think of this. Let's say this is a mixture of a non-ideal solution. Okay, so you have 3/4 of the 3 portion of the thing. Okay, one is pure water. Okay, one is pure water. This is blue color represent pure water. Okay, and then one of them is nitric acid. So I'm going to put yellow color as the nitric acid. Okay, and you have a mixture of azeotropic mixture. So I'm going to put purple color as the azeotropic mixture. So purple color is the azeotropic mixture. So it depends on what distillations that you are going through. If in this case, you can see that you start from 30% of the hydrogen, okay, 30% of the water. So you vaporize, condense, vaporize, condense, vaporize, condense. So until the blue color is until the first distillate in here will be water. So water first distill out already. So water gone, isn't it? Okay. And then you continue distillate. Now only nitric acid, azeotrope and also nitric acid. So if you continue second distillate will be azeotropic mixture. So this will become the, okay, I used the highlighter just now. So at the end of the day, you still have the, what is inside here, the remaining inside here is the HNO3, pure H2O with the remaining solutions in here, okay? So that is how you are going to explain. First distillate is the nitric acid, second distillate is the azeotropic mixture, and then the residue is the impure water, okay? So the answer is going to be C in here, okay? So that is how you're going. Sorry, if you want to know more about this fractional distillation, you can go to my YouTube that I explained about phase equilibria. Okay, so you can go there later. Okay. Okay, so with that, that is all for the 15 objective questions that you are asked to solve. Okay. Okay, so I'm going to take 1 minute's break. When we come back, we continue with the structure. Okay. Okay, so sorry, I went for toilet for a while. Okay, shall we continue? Okay. Yeah, so hopefully you are able to understand what we are going through so far, and we are about to go for the structure questions already. Are you all ready? Okay, so let's have a look at the structure questions, shall we? Okay, so diagram below shows several spectral lines of the Balmer series in the emission of the hydrogen atom. Okay, so from the energy level diagram below, sketch the transition of electron for the formation of the line of spectrum X. Okay, so in here you are asked to show the formation of the spectrum X. Now, even though there are a few basic things that you need to understand in here. So this is the Balmer series. So if it is a Balmer series, your transition element, your transition energy levels in here will be ground state lah, ground state. So your ground state will be n equals to 2 lah. So your n will be equals to 2. So make sure that when you draw your energy level line in here, all of the electron will eventually fall at the energy level n equals to 2. Okay. Okay. So the first mark will goes to sketching the energy transition. So you must make sure, okay, inside here, the N2 to N1 will have the largest gap. Okay, this is the tips of how you are going to solve STPM. You have to make sure that between N1 to N2 you have to draw this is the largest gaps. Okay, and eventually the gaps become smaller and smaller. Okay, becomes smaller and smaller lah. Okay, and then actually you only need to draw until n equals to 5 already, as long as you show that this is the third line. Okay, this is the third line. So a third line is the result from the transition of electron N5 to N2. So if you can't understand the transition from N5 to N2, then if A is wrong, automatically B will also be wrong already. Okay, because the B asks you to calculate what is the energy required, or what is the energy release or energy transitions occur in here. Okay. Okay, so 1 mark goes for sketching energy level. 1 mark goes for the falling of the electrons. Okay, from N5 to N2. Okay. Can you understand? Any questions so far? Okay, so hopefully no problem. Okay, so this is 2 marks. So calculate the energy required for the transition of an electron to form line spectrum X in the Balmer series. So in here, you have to use the Rydberg equation. So 1 over lambda is equals to RH times 1 over N1 square minus 1 over N2 square. So this one you have to memorize. I'm so sorry, you have to memorize. So no choice. All the constant is given to you in the questions already, isn't it? So you have to write out the substitution, okay? And then you have E equals to HF, or E is equals to H times C over lambda, or straight away, because 1 over lambda is equals to the 1 over lambda is equals to 1 over N1 square minus 1 over N2 square. I think I lack of the word RH. EC, wait, sorry. Yeah, lack of 1 over lambda. Yeah. Okay, so in here, E is equals to HF, or E is HC times 1 over lambda, or HC times RH times 1 over N1 square minus 1 over N2 square. So you substitute all the constant inside there. So you got 4.95 times 10 power of negative 19. No, Mr. Chu so clumsy. Sorry. Mr. Chu clumsy. Mr. Chu forgot to put 1.10 times 10 power of 7. Hey, sorry. Inside here. Oh, okay. No. Correct. Okay. What happened to me? Sorry. Correct. Okay. So correct. Sorry. Because I already okay. I already calculated the wavelength already. So it's 2.31. This 2.31 times 10 power of negative 6 come from here. Okay. This 2.31 times 10 power of negative 6 come from here. Okay. I already substitute 1.10 times 10 power of 7. Okay, this one is come from here. So you get 4.59 times 10 power of negative 19 joule. If you look carefully at all the constant has 3 significant figure. So your final answer should also have 3 significant figure inside here. Okay, and the unit in here is joule. Okay, so that is for B. So this 16A, do we need to include n equals to infinity? Wait, I post your questions. Okay, question asked, teacher, in question 16A, do we have to include n equals to infinity? You don't add also, never mind, because the crucial in here is to show the transition from N5 to N2. So you don't put also, never mind. But even if you put, it's not wrong, okay? You won't get minus mark because of that, okay? Okay, and finally for C, sketch the transition of the hydrogen spectrum. So you draw exactly the same as in the question. When the questions give you that set of spectrum and then ask you again, sketch the line of emission spectrum of the lithium ion. So you are going to repeat back what the question sketch inside there. Okay, don't decrease one line, don't increase one line, don't. Follow exactly the line spectrum given. So teacher, why are they the same? So here is the thing. Why are they the same? Because both of them are single electron system. Both of them are single electron system. So that is why you expected for both line spectrum to be the same, no matter it is a hydrogen atom or Li2 plus ion. Okay. Okay, so that is for number C in here. Okay, any questions? Yeah, so if no problem, so that is for number 16. Okay. Okay, ready to go for the next one, 17? Can Okay, so let's go to the 17. Okay, so 17 asks the allotropy. When I set these questions, I just try my best to encourage students to study some of the very small subtopic that usually haven't come out in Stpm. So far, if after the analysis, one of the subtopic that I analyzed that not yet come out throughout the new syllabus system of the Stpm is allotropy. Allotropy long time didn't ask already, so that is why I purposely set for this one. Teacher, can you explain 16B again? 16B, why? Simply just substitute the equation. Simply just substitute the equation. This one is N2 square. Okay, how to get frequency? Frequency because F is equals to C over lambda. Okay, or equals to C times 1 over lambda. So 1 over lambda is equals to this one, correct or not? So substitute straight away into here. Okay. Okay, so try your best to write out all the equations in here. So equations also have mark, equation substitution answer, equation substitution answer. So that is how you get to this one. Okay. Okay, so that is for 16 just now. 17, table below shows the structure of allotrope for carbon. You have diamond, graphite, and also fullerene inside here. A, define allotropes. So what is allotrope? So elements with the same state of matter but different structure or different form. among the most common allotropes that you in our Stpm syllabus is diamond, graphite, and fullerene. Allotropy of carbon. Allotropy of carbon. In a very, very old past year question, they even asked about allotropy of oxygen. Allotrope of oxygen is ozone. Allotrope of oxygen is ozone. Okay. Okay, so there is A, elements with the same state of matter but different structure or different form of different crystalline structure also can. Okay. Okay, B, complete the table by filling the blank with the hybridization of the carbon atom and electrical conductivity for each allotropes involved. So diamond is sp3, graphite is sp2, fullerene is also sp2. In terms of electrical conductivity, diamond is insulator, graphite is a conductor, fullerene is actually insulator. Okay, fullerene is actually insulator. Okay, so these are some of the basic characteristics that you have to try your best to remember for the allotropy of the carbon in here. So why is if you can see from the structure in here diamond, it is sp3, so there are no delocalized electron. Graphite sp2 because in the hybridization of the sp2, okay, inside the graphite, so because the graphite you have one unhybridized 2 pz orbitals with one single electron in here, isn't it? Okay, so so the unhybrid electron delocalized inside the in between the layer. So when the unhybrid pz orbital will delocalize between the layer, so that is why they can conduct electricity. But inside the fullerene also actually contain the unhybrid electron, but the electron is delocalized inside the ring here. Electron is delocalized inside the benzene ring. So when electron is delocalized inside the benzene ring, hence stabilize the structure. So the electron does not help to conduct electricity. So that is why fullerene in here is an insulator. Okay. So this is the difference. Why is it that? Then the question number C followed by that ask. Based on the table in B, explain the conductivity between graphite and fullerene based on the structure involved. So this graphite is an electrical conductor due to electrons are delocalized between the layer structure, hence conduct electricity. But in the fullerene, electrons are delocalized within the ring structure to stabilize the fullerene, hence you cannot conduct electricity in here. Okay. So this is the reason why you cannot conduct electricity for the fullerenes. Okay, try your best to know on how to explain why is it that they cannot conduct electricity. Okay, quite important. In fact, a lot of books they didn't really explain that, so you have to know by yourself. Okay, D, state an application of each allotropy of the carbon. So diamond is a jeweler, can apply as jewelry or diamond cutter. Graphite is electrode in laboratory. It can also act as a lubricant. And then fullerene, drug delivery system in human body, lubricant, and also catalyst in here. Okay. Why fullerene is an insulator? Fullerene in N-type semiconductor that are widely used in industry. In here, we are talking about Buckminster fullerene. I know some of the fullerene are used as a N-type semiconductor, but in this case, specifically refer to this structure. This is a Buckminster fullerene. If you check on Buckminster fullerene C60, it is actually an insulator. Okay. So those which are other than C60, some of them may act as an insulator because in the this fullerene structure fullerene structure, they can have the carbon nanotube structure, correct or not? Okay, so this one. So teacher, how to know the hybridization or orbital of a molecule is sp, sp2 or sp3? It depends on how many covalent bond are surrounding them. So this one, I'm so sorry, you have to go and visit my YouTube. Explain them in chemical bonding. Okay, I cannot explain here because of the time constraint. Okay. Okay, so that is for number 17. Any other questions? Okay, so hopefully no problem. Okay. Okay, now finish the structure straight away. We go to the essay questions. So hopefully you have you have tried your best to answer the essay question. So we are going to discuss the essay question here. Now, because of different proportion of the isotopes, relative mass of the lead depends on its sources. 2 samples of lead were subjected to analysis. So lead sample A, mass spectrum of the first sample was taken and the following results were obtained. So you have MOVE value 204.0, 206.0, 207.0, and 208.0. So relative abundance is 27.0, 48.0, 41.5.0, and 100.0. Now, if you look carefully, all of them has 0.0 behind that, isn't it? So your final answer should also have 0.0 inside them. A, calculate the relative atomic mass of lead from the analysis of the mass spectra. Unprofessional notes. Oh, okay. So relative atomic mass of the lead is 204.0 times 27.0 plus 206.0 times 48.0, 207.0 times 41.5, and then 208 times 100. So you get 27.0 plus 48.0 plus 41.0 plus 100.0. Now, the key in here is to substitute as exactly given to you in the questions. Okay, the key in here is to substitute as exactly given to you in the question. So, and then if you notice carefully, all of them has 0.0 behind that. So your answer should also have 0.0 lah. Okay. Okay. So this is for A. Okay, so hopefully you'll be able to answer. Okay, can So immediately we goes to 18B. Okay, so let's sample B. When 1.000 gram of a second sample of lead was burned in excess, was burned with excess chlorine, a total of 1.341 gram of lead-2 chloride is formed. Okay. Assume that the yield of form is 100%. Calculate the relative atomic mass of the second sample of lead in here. Okay. So in here, they give you the reaction. So lead burned with excess chlorine to form lead-2 chloride. So this, whenever a chemical reaction is given to you, definitely you have to write the equations, chemical equations. So Pb plus Cl2 give PbCl2. Okay, so that you know stoichiometrically, one lead react with one chlorine gas to form one lead-2 chloride. Okay, so you see the mass of the lead is 1.000 gram. The mass after burning, total of lead-2 chloride is 1.341. So what is the mass of the chlorine in here? So the mass of the chlorine in here is 1.341 divided minus by 1.000. Okay, so your mole of chlorine will be 0.341 divided by 2 times 35.5. You get 0.4803 mole. Okay, then stoichiometrically, one chlorine is to one lead. So your relative atomic mass of lead will be 1.000 divided by 0.004803. Therefore, the relative atomic mass of lead is 208.2 in here. Okay. Thank you very much for all of you who try your best to help among each other. So sometimes when I explain, I use very deep meaning. If you are able to converse into a simpler meaning and help your friend, you yourself at the same time you also learn. I actually learn that when you try your best to explain to your friends, you yourself is also learning at the same time. So thank you very much for those who are this one. Okay, this fly with CR is it a must to write physical stat in the equation? Actually, no need. In Stpm semester 1, the only chapter that you require to write the state of matter is when you express the heterogeneous equilibrium, the KSP one. When you are expressing the equation for the KSP, state of matter is a must. Okay. Okay. So does question A2 can be calculated using ratio methods? Do you get the same answer in here or not? If you get the same answer, then anything will be is fine. Actually, in STPM, there are actually more than one type of solutions. More than one type of solution. If the solution gets to your answer, then all are acceptable actually. Okay. But in this case, it is very specific. The increase of the mass is due to the increase of the chlorine. So you have to calculate based on the chlorine in here. Okay. Okay. So if you have solution, maybe you type out and then we'll see together. Okay. While I continue on, you type out your solution and then we check together. Okay. Okay. Very good. If you get the same answer, then okay lah. Okay. Okay, well done. Okay, C. From both lead sample A and sample B, determine if both of them were from the same abundance. Explain your answer. So in here, definitely it is sample A and B are different because D has relative abundance of the lead isotope compared to A lah. Okay. Okay. Thank you very much for helping me to answer. Okay, thank you. Okay, so that is for number 18A. Ken? Okay. So we goes to 18B, shall we? 18B. Okay, so 18B, lead 2 chloride, lead 4 chloride has different melting points as described in the table below. Based on the structure and bonding, explain the difference of melting between lead and its compound. So that means you need to explain why lead has such the melting point, lead 2 chloride has such high melting point, lead 4 chloride has such low melting point. Sometimes I tell you, this kind of the question is advantage to the Ulangan 1 student because Ulangan 1 students, you already experienced semester 2, correct or not? And semester 2, you already learned the structure of PbCl4, PbCl2, and Pb lah. Okay, so do I draw the Lewis structure or not? I didn't. Okay, so allow me to draw out the Lewis structure for you so that you know what is going on. Lead is of course lead lah. So lead 2 chloride is actually made of Pb2 plus and also 2Cl minus. Okay, so as you can see, it is the covalent bond. It is an ionic bond, covalent bond, ionic bond. Okay. Why calculate the RAM? Hey, Le Yingqing, come on, Le Yingqing. You've forgotten the basic already, is it? Okay. Wait, let me draw the Lewis structure of the PbCl4. Okay. So, teacher, how do we know PbCl2 is ionic, PbCl4 is the covalent? I'm saying this for sure. Okay. I'm saying this for as a guideline. For some of you, if you that's why I said SEM to Ulangan 1 student has a slight advantages in this paper is because they have experience. They know how PbCl4 looks like. In the STPM semester 1, you not yet learn PbCl4. So you don't know how the structure looks like. So teacher, how do we know that it is an ionic bond or covalent bond? Generally, covalent compound has a very low melting point. So in this case, it's until -15. So by hook or by crook, you try your best to understand that when a substance has a very low melting point, that means below than the room temperature, it's probably a covalent compound. Okay. So that is how you tell whether it is an ionic or covalent. Okay. Okay. So shall we continue? Yeah. So now, one of the tips that helps you to understand whenever we are talking about melting point, boiling point, it has definitely something to do with the bond and structure. It is definitely something to do with the bond and structure. So you must know by yourself, metals are held by metallic bond. Metals are held by metallic bond. And the way of how you write their structure, you write like this. Lead are held by metallic bond where valence electrons are delocalized to form the electron C and interact with the metal ion. If possible, add the word valence. It is the valence electron that delocalizes. Okay. Okay, it is the valence electron that delocalized to form the sea of electron. We call it as electron sea, hence interact with the metal ion. Okay. Okay. So that is for that. Okay. Sorry, I accidentally pressed 2 times of this one. Sorry. I accidentally pressed 2 times. Sorry, I accidentally pressed. Okay. Then for lead-2 chloride, so this is the way of how you are going to write for the structure of the ionic compound. Why ionic compound has a high melting point? So you write like this. Lead-2 chloride is an ionic compound which are held by giant ionic crystal lattice. Okay. Okay. So once you later I explain. Can I finish this one first? Okay. So when you write for lead-2 chloride, okay, so you have to write in such way. So it is an ionic compound that are held by giant ionic crystal lattice via electrostatic attraction forces between the oppositely charged ion, if you want to add lah. Okay, but electrostatic attraction forces is far more than enough already. Okay, and finally, when you try to explain a covalent molecule, so you explain like this. PbCl4 is a simple covalent molecule held by weak van der Waals forces. Simple covalent molecule held by weak van der Waals forces. Okay. So question asked, the drawing of the structure got marks or not? I'm so sorry. In this case, you don't have marks in here. Okay. Though it does helps you to understand, helps you to explain. Okay. 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 So I'm going back to this one. I scroll back to the. Okay. Okay, so one of your friends asked like this. Can I? Okay, so hi sir, just a question. For relative atomic mass, right? Do we still write as Al to represent atomic mass, or now change to using L? Actually, they don't really mind about what you use to represent, as long as you know what you are calculating. Okay, they don't really mind. The symbol of the formula is not extremely stressed. Okay, so don't worry about that. Okay. Okay. Okay, so I repeat in here. So for how you describe metal, so you said that metals are held by metallic bond where valence electron are delocalized to form electron sea to interact with the metal ions. And then for ionic compound, you say that ionic compounds are held by giant ionic crystal lattice via electrostatic attraction forces. And then if it is a covalent compound, you describe as a simple covalent molecule held by weak van der Waals forces. And then actually there is also one more structure, which is the giant covalent structure. So giant covalent structure, as you can see inside the question 17 just now, this diamond has a giant covalent structure lah. Diamond has a giant covalent structure. One more that has a giant covalent structure is the silicon dioxide. So you can go to the chapter 4 to understand further about the structure inside the solid lah. Okay. Okay, so with that is all the question asked in essay question number 18. Okay. Okay, any questions that you want me to re-explain to you or make you understand better about this question 18? Now, if you have, you can always type the comments down there. And then if any problems, I'll come back to your questions again. Okay. Okay, so with that session, let's move to question number 19, shall we? Okay, so let's go to question number 19. Carbon atom uses hybrid orbitals to form organic compounds such as propyne, CH3, C-triple-bond-H. Using energy level diagram and hybrid orbital diagram, describe the hybridization involved and state the shape and angle for each carbon involved in here. Now, why I purposely choose this one, because it has been such a while that they didn't ask about the structure lah. So yeah, they asked in 2015. 2015 is even more difficult. You have to draw the Lewis structure for Cn minus and also this CONH. So to those you want to know what is the question all about, you can go to the 2015 Stpm questions to know what is the questions there. Okay. Okay. So now highlight the word using energy level diagram. Okay. And hybrid orbital diagram. Describe the hybridization involved. State the shape and angle for each carbon involved. Okay. Okay, so for you all, I will usually definitely advise you all to start from, okay, you have to start from ground state. Okay, ground state of the carbon is 2s2, 2p2. Then you explain excited state. So excited state, you make the energy level between the 2s and 2p to be equal. So each of the S and P has one single electron inside there lah. Now in hybridization state, so C1 has sp3 hybrid. Okay, inside the covalent structure you have CH4 CH3, okay, and then C triple bonds CH. Okay, so this carbon number 1 is sp3 hybrid. Carbon number 2 and carbon number 3 are sp hybrid. Okay, if possible, explain in details. Okay, let's say that C1 is sp3, C2, C3 is sp hybrid. Okay, so if C1 hybrid, so how do we know if sp has lower energy level than P? It is usually like that. Or when you form a stable structure, hybrid orbital is considered stable already. So when it is stable, then you have a lower energy level. So usually that is the way of how we describe. Okay. Okay. Then you draw sp3 as in like this, then sp as in like this. Okay. Okay. And finally, you draw the orbitals diagram. Okay. Okay, so this is the orbital overlapping diagram in between here. I know because this is computer type So teacher, definitely you can draw beautiful because you use computer to type. But actually, even if you use hand draw, you should be able to more or less express all that Okay, okay, and then now as a student, you don't care where are the marks located. Just try your best to fully label the diagram, including the pi bond and also sigma bond. So that is my advice to the students. So that is why when I teaches you all to answer in essay question, I will definitely advise you all to write everything inside the essay questions. Okay. Okay, so CH4 in here, you have a sigma bond, sigma bond, sigma bond, sigma bond. So C triple bond C, you have 2 pi bond, 1 sigma bond. And then the CH in here, this is also sigma. I think I left out in here. This is also sigma bond. Okay, okay. And then this CH4 is tetrahedral, so 109 degree. And then this shape is linear, which is 180 degree. So with that, you are able to fully describe the bonding and the structure inside the hybridization of the propyne molecule, CS3C triple bond CH in here. Okay. Okay. So any questions that you want to ask about this hybridization concept? Okay, so if you have later, you can type in, then I will come back to this and discuss with you. Okay, okay, so that is for 19A. Okay, 19B, both ethyne and nitrogen molecule contain triple bond. The reactivity of ethyne is greater than that of nitrogen. Explain the difference of this difference of the reactivity in here. Okay, so these are more towards why nitrogen has why ethyne has a greater reactivity So it is because nitrogen has a short and strong triple bond with high bond energy. So that is why nitrogen is inert Okay. You might also want to put one more statement that you might want to put. You must also state that nitrogen atom is smaller than carbon. Just put there. Nitrogen atom is smaller. So it is because the nitrogen atom is smaller, okay? That is why the bond length is shorter, okay? So both of them has triple bond, but nitrogen has a shorter and stronger triple bond. So that is why it is more inert, okay? Okay, so that is for B. And then finally for C, nitrogen oxide can form as nitrogen dioxide, NO2, nitrate ion, NO3 minus. By drawing the Lewis diagram for both NO2 and NO3 minus, state the shape and angle for both molecules involved. Now, this is a very, very specific structure that I purposely pull out because, well, you never know Stpm what question they will ask, isn't it? Nitrogen dioxide is a very unique structure because it has what we so call as a radical in here. Okay, so the question one, Lewis diagram, angle and shape only, isn't it? So you just express them. Okay, so nitrogen, you must have this single electron. This single electron is what we so call as a radical. Okay, and this is the only structure accepted in here. Teacher, I thought this nitrogen monoxide have dative bond, right? So do we really have to draw out the structure of the dative bond in here? Actually, you don't need to really draw out the structure of the dative bond. Actually, dative bond is also a covalent bond. So even if you don't specifically draw out dative bond, it is okay. We accept in Stpm. So don't worry about dative bond. You only need to especially careful with the dative bond on two things. Number one is the dimer of Al2Cl6 or Be2Cl4. That one you have to specifically mention the dative bond. And then one more is the this formation of the complex ion. That one you also have to especially express that it is a dative bond. But if normal covalent structure such as like this, actually no need to really stress that it must have a dative bond. And then teacher, I see a lot of books when they want to express the nitrate ions, they express we see the books they will put this bracket. They will put this bracket NO3, then they put minus. Can we accept this diagram or not? To be honest, I am not 100% sure whether they will accept this NO3 minus or not. But from the previous experience, when they want students to express CN minus, that year, they specifically want students to put the negative on the carbon. This is the Lewis structure of the Cn minus. So they specifically want students to state the negative charge on the carbon in here. Okay, if you put as bracket Cn, then they are not going to accept. Okay, so and then one more here is the sulfuric acid. In the sulfuric acid, the sulfate ion Lewis structure is drawn like this, you know. Okay. So in here, sulfate ion, try your best to draw the negative is at the single bond oxygens in here. So teacher, how do we know where which atom will carry positive, which atom carry negative? It will be back to the formal charge that we discussed earlier. Remember earlier we have the formal charge that we discussed. Okay, so you try to apply the formal charge in here. But one of the quick notes in here, one of the quick notes in here is if double bond O, I tell you, if you have double bond O, such as like this, double bond O usually formal charge is equals to 0. Okay, then single bond O, formal charge is usually -1. Okay. Okay, one more that you have to take notes, if N has 4 covalent bond, okay, nitrogen with 4 covalent bond, definitely will carry a positive, okay. These are indefinite truth, okay. And then the rest of it, carbon with one lone pair electron usually contain negative charge. Carbon with one lone pair electron usually contain one negative charge. Okay, and then carbonate. Even for carbonate, you should also draw like this. You know, I would usually recommend students to draw carbonate as in O minus like this. Like this. Okay. Of course, with the lone pair electron, so you draw nicely, okay. When we say Lewis diagram, you must include all the lone pair electrons inside the diagram. Okay. So these are the four polyatomic ion that you need to know in STPM. STPM we stress CO3 2 minus, NO3 minus, Cn minus, and also SO4 2 minus. So these are the polyatomic ions that you want to remember well. Okay. Okay. So with that, that is how we solve essay question number 19. Okay. Okay. Any questions that you want to ask for essay question number 19? Okay, and last but not least, a little more steps in here. If you see you have to be, sometimes you have to be very smart on reading the mark. If there is 6 marks, then you have to know each of them you have to write 3 things. But because this essay question is very specific, draw the Lewis diagram, state the shape, state the angle. So one of them each. Okay. If you worry, you might also want to write this contain two bond pair electron, okay, and then one electron, one lone electron. So the structure is bent. This one is 3 bond pair electron. Of course, in STPM, you cannot write abbreviation. This one is Mr. Chu will write one. No lone pair electron. But in the real STPM examination, you cannot write abbreviation. You must write in full sentence. Okay. Okay, so that's the thing. So for the Lewis diagram, these are more or less the things that you have to write on inside your structure inside there. Okay. Okay, so any else question? Okay, so no problem. Then that is for question number 19. Can you go on to the question number 20? If you have any question, you can type in. I'll try to come back with the comments and answer to you. Okay. Okay, question number 20. Decomposition of phosphorus pentachloride PCl5 to form phosphorus trichloride PCl3 and chlorine gas Cl2 are shown below. So PCl5 give PCl3 plus Cl2. Given the equilibrium constant Kp for the reaction under different temperature, where you have this series on the table, using graphical methods, calculate the enthalpy change of the reaction. So given to you, gas constant R is 8.31 joule mole minus 1 Kelvin minus 1. Now I purposely pull out this we call it as a Van Hoff equations because in STPM 2014 they asked about these Arrhenius equations already. Van Hoff equation was asked in 2015. Teacher, is table form accepted for answer? Yes. Table form is accepted in STPM. Chemistry at least I know for chemistry they accept table form. Actually, we when we as a marker, we usually love to see students write as simple as possible, easy for us to mark. Okay, correct is correct, wrong is wrong. Okay. Okay, teacher. Okay, so I scroll back to the just now. So that this one. Sorry. Some of the comment goes like this. Teacher, in STPM, we only write the angle of the bend shape as less than 120 degree, or has another shape that has STPM question that we need to write angle and what the angle is what angle. Okay, I can try to understand what you're trying to ask in here is for the angle. You don't write the word less than 120. Cannot. You must specifically give a number. Okay. So usually we advise students to specifically give a number. Okay, don't say less than 120. No. So we accept somewhere between 104 to 119. Okay. So is there an exact number? No, there is no exact number. But one of the things that have exact number is the one with ammonia. Ammonia is 107, no? Then water is 104.5. No? So if you want to say specifically if lone pair electron will influence the angle, so that is the two angles that we say that it is influenced in here. Okay. Okay. So for the angle, you might want to look at if you look at some of the exercises from my books, you can also refer to my YouTube channel there for the answer. Even if you don't buy the books, you can still look through the exercises because I explain in quite details of how to answer. So you can see some of the angles of how the molecule should look like. Okay. Okay. So I hope that I answer to your questions. Okay, so shall we continue to last question number 20? Okay, so back to this one. So you have to use the Van Hoff equation. Whenever you are trying to use the Van Hoff equation, definitely the first thing that you have to do is to express Van Hoff equation. This kind of the essay question, if you cannot remember the answer, the equation, then you better don't attempt this essay question. Okay, so some of the students, they see table, they know how to plot graph, they see graph paper, they love, but they don't know that what they are doing. At the end, they only get 3 marks. Teacher, 3 marks is better than no mark. If you feel so, then go ahead. I won't stop you. Okay. That 3 marks is given provided you plot the graph correctly, you know. So you plot wrongly, then no marks. Okay. Okay. So now once you express the Van Hoff equation, ln K is equals to negative delta HRT plus C. So you have to replot the table again. So you replot as 1 over temperature and ln kilopascal, Kp, sorry, ln equilibrium constant Kp in here. So you get this following table. Please, when you want to plot a graph, and then you sketch a table, my advice to you, this is now Stpm level. Stpm level, all of the tables things must at least has 3 significant figure. Some of the students, because you want to be very convenient in your graph plotting, you will start to write only 2 decimal place. This one you write as 0.17. Okay, this one you write as 17. Okay, this one you write as 14. This one you write as 113. This one you write as 11. This one you write as 1. Please do not use 2 decimal, 2 significant figure. I tell you, this is Stpm level minimum 3. Okay, so that later when you plot your graph, it will be a good graph inside there. Okay. So please at least 3 decimal or 3 significant figure. Okay, don't curi tulang. Okay. Okay, so that is my advice to most of the students when you are trying to plot the graph. Actually, even this 0.435, I accidentally only put 1, but actually you require 0.821. Okay. Okay, so you must put as 3 here. And then when you plot the graph for such questions, okay, when you plot the graph for such question, so you have to plot nicely inside the graph. So this is the expected graph. You can shorten the graph. You can start from 0.95. You don't have to start from origin. You can start from 0.095 to 0. So you make sure that you plot your graph carefully on everything. So in here, if you notice carefully here, do you see that the line in here does not even intersect any of the point? Because inside a good graph is to find a balance in between the points that you already plotted. Okay, so once you already have the graph paper, you plot your graph accordingly. Okay, so yeah, very good question. Teacher, thank you very much. This fish shark. Teacher, if we write 1.67, then put times 10 power negative 5 as 1 over t, can? Yes, can. You see my answer, I write as 0.00. You can actually put in a standard form, yes. However, because later you are going to calculate gradient, isn't it? So some of students that I sometimes I mark paper, I witness some of the students, they put times 10 power of negative 3, they later forget to substitute inside gradient. So the number of the gradient become very big. It's actually very become very small, sorry. It's actually very big value, but because you forgot to substitute times 10 power of negative 3, so at the end, you lost some marks inside there. So my advice for students, if you want to prevent forgetting to put the standard power of how many, so I will usually recommend students to put 0.00, unless that 0.00 is very small, 0.000016, so which is equals to 1.67 times 10 power of negative 6, let's say. That one is ridiculous, you cannot put 0.000001. So you can use standard form by that, 1.67 times 10 power of negative 6. But in this case, it's just 3, that means 3 decimal place, that times 10 power of negative 3. So it's not that big. So for me, if I were a student, I takut I lupa nak ganti, so better I put in the point form, in the decimal place form. Okay. Okay, so once you get your graph looking like this, so usually in the graph, axis, labeling axis 1 mark, I forgot to label. Can you help me to label inside here? Okay, this graph is this graph is ln kb against 1 over t. So please plot carefully inside here. Okay, so and then this one. Okay, so this is a graph. So can we go on to the calculation part? Okay, so for calculation part, so the gradient, you use any 2 points in here. In my case, I use 6.0 times 10 power negative 2 minus negative 1.20 divided by 0.00156 divided by 0.00125. So delta H over R is equals to gradient, or delta H is equals to 3877 multiplied by 8.31. So your final answer is negative 32.2 kilojoule. Teacher, can I put as 3.22 times 10 power of 4 joule? Also can, no problem. Okay, and then this one, because this delta H can be positive, negative, this sign is very important. You must put the negative sign in front of it. Okay. What else that I need to highlight? Teacher, what is the accepted range? Accepted range in here is from 2.9 until 3.5. Okay, that means 29 kilojoule to 35 kilojoule all are accepted in this case. Okay. Okay, any questions? Okay, so some of you asked the question 19 just now. Can I scroll back to question 19? Question 19. Okay, this one. Some of you asked about this question. Sir, how about NO2 minus with band shape, nitrogen form 2 bond pair, 1 lone pair, then 1. If drawn like that, is it wrong? You actually, in the Lewis diagram, you don't really have to draw out as a band shape. Even if you draw like this, my dear. Now, even if you draw like this, let's say nitrogen, this one, you draw as N double bond O single bond O, you draw like this, it's not wrong. It's not wrong. The most important thing is the number of lone pair bond pair is correct. Whether it is band or not, it's not important. Okay. Okay. Whether it's band or not, it's not really that important. Okay. Don't worry. Okay. I hope that I answer your riddles. Okay. Okay. So back to the question, Ken. Okay. So okay, so this is it. Okay, so from the graph in A, determine the equilibrium constant of the partial pressure Kp at 650 Kelvin. Hence, calculate the degree of the dissociation. Okay, so in here, so you look at the graph 650K. So 650K 1 over T is 0.0154. So this one is a very subjective question because it depends on your graph. So you check lah, 0.0154. Okay, so 0.0154. So your 0.0154 is here, lor. So based on your graph, is that this 0.0154 is based on your graph in here. Okay. So from my graph in here, I just use my graph as a reference. So you get 5.60 5.60 as you can see from the graph in here. I get 5.60. Okay. Okay. So that is why ln K is equals to 5.60. So K is 221.4. So you use the equilibrium PCl5 give PCl3 plus Cl2. So because in here I don't give you any mole, so you can simply assume it's 1 mole. So 1 mole of the PCl5. Oh, sorry. Sorry. I accidentally pressed 2 times this one. Sorry. I'm so sorry. For that one. Okay, so 0.0521. So you get your K is equals to 22414. So you use the initial degree of dissociation alpha. So this one minus alpha, this one plus alpha. So at equilibrium, you have 1 minus alpha. So this one is alpha, this one is alpha. So total mole 1.0 minus alpha and alpha. So total mole is 1.0 plus alpha. So you calculate the partial pressure for PCl5, PCl3, and PCl2. So the PCl5 partial pressure is 1.0 alpha, which comes from the mole of the PCl5, and then divided by the total mole. So total mole is 1.08, and then the total pressure under 101 kilopascal. Okay, so times 101 kilopascal. So this is the partial pressure of PCl5, and then PCl3 and PCl2 are the same. So you have A, okay, which comes from here. Okay, divided by 1.0 minus plus alpha times 101 kilopascal. So you express your Kp. Kp is equals to PCl3 times Cl2 over PCl5. So you get 2.21 times 10 power 0.4. So A times 1 minus alpha plus 101 kilopascal square. Okay, because there are 2 over 1 minus alpha times 1 plus alpha multiplied by 110. So press your calculator, you get your alpha equals to 0.0521. Okay, so that is how you calculate your answer in here. Okay. Okay, so that is how you're going to solve for 20B here. I purposely pull out this question is because long time they didn't ask such method of how to calculate Kp. So in our situations in here, I just wanted you to understand when you want to calculate Kp, you must try your best to draw this table. Okay, you must try your best to draw this table, initial degree of dissociation and equilibrium. Then your first step is you have to calculate total mole. After you calculate total mole, you have to calculate the partial pressure for each of the gas involved. So in this case, it's PCl5, PCl3, and Cl2. And then only then you express your Kp and substitute each of your partial pressure inside your answer. Okay, then you'll be able to get your answer eventually. Okay. Okay, so that is how you are going to answer for 20B. Sometimes a question like this can be very difficult. So if you have no confidence in solving this kind of a question, so there are 2 more essay questions. So you must choose your question wisely. So I believe most of the students will try to avoid this part, but some of the students, they see graph, they're very happy. They do the graph one without knowing that they only can get 3 marks. So you have to read your question carefully lah. Okay. Okay, so I guess that is all for the essay questions that I wanted to discuss with you. So now is the Q&A session. Okay, so if you have any Q&A sessions, you can always feel free to ask me. My time is until 6:20 lah. Okay, 6:20. So there are 10 more minutes left. So any 10 minutes you want to ask any question, I allows you to ask any question that you want. Okay. Okay, so some of you has already started to type inside here already. Okay, so sir, is got two type of NO2 or not? Is one NO2, one is NO2 minus. NO2 and NO2 minus are two different substance. So NO2 minus is got lone pair electron, NO2 is radical. That's what I can say. Okay. Okay, so is it unique for NO2 for that one electron, sir? Because only 7. Yes, it is unique. If you look into my introduction, you go to my YouTube and you look for the there are exceptional. I have one special subtopic called as exception of octet rule. So you go to that. It explain that. Okay, not only NO2, NO also contain radical. Okay. Okay. Sir, can we use SEM 2, SEM 3? Of course you can, no problem. Of course you can, but usually you don't apply that much. SEM 2, SEM 3, they are more advantageous in structure only because you learn organic and you learn inorganic. So you are more advantageous in structure only. The rest is still the same as SEM 1. Okay. Okay, what else? I'm so sorry lah. You can only type. You cannot speak to me directly. I don't know if there is a way that you can speak directly to me unless you use Zoom lah. If I use Zoom, then Zoom limited the number of participants, isn't it? Use Google Meet. Google Meet very troublesome one. I don't like Google Meet, to be honest. So I feel that this YouTube is one of the best way. Plus YouTube, it automatically save in YouTube, so you don't have to keep on transferring file here and there. You don't have to ask, teacher, where is the video last time? So YouTube is the most convenient for me. Okay. Okay, what else? What else? If you are looking for more exercises, you can. All my question papers are downloadable. You see any of my technique menjawab on YouTube. Usually down the link there, I have the link to the question and answer. So you can try your best to answer as much questions as you can. Okay. Okay. So do you have any recommendations who find hard to learn chapter 6? That's why chapter 6 is the most. Actually, chapter 6, like in this case, it come out with essay question, isn't it? Don't do chapter 6 question. But if it is in structure essay, if it is in structure, then no choice. Okay. Just try your very best. Just try your very best. I know it's very hard to master. Yes, I know it's very hard to master. So I will only say that just try your best to study. But if you really cannot understand chapter 6, there are 5 more chapters, isn't it? Why don't you focus more on the chapter that you are able to understand better, chapter 1 to chapter 5? Because so far in Stpm semester 1, only one question, one chapter. 16, 17, 18, 19, 20. 16, 17, 18, 19, 20. So 5 chapters. So 1 chapter, 1 question. Usually that is the style. So if you don't know how to study chapter 6, then focus on other chapter. Okay. Teacher, can we write chemical formula for explaining, for example, ClN2, meaning Cl2. Oh, can. You can use formula to not use word. You can use formula. Can, no problem. Chemistry, chemistry definitely. Why do we invent formula? Okay, unless the question said name the compound. Name is you have to write the name, okay? But if in our normal situation, we can use formula. Okay. Sir, may I know in the question the Stpm chemistry paper is unpredictable? That means some questions are related to syllabus, need to do more research. No need. Most nowadays Stpm questions are more to inside the syllabus already. They rarely ask out of the syllabus already. Even if they ask out of syllabus, they only 1 mark only. One or 2 marks only at max. Don't worry. Why focus on 1 or 2 marks if you have other 58 marks to score, right? Teacher, what is the hot chapter always come out in Stpm? Okay. I share with you this. Wait, wait, print screen. Wait, can you help me hold 1 second? Try to share with you this one. Actually, there is no such thing as hot topic come out on which chapter because at the end of the day the questions in here okay, so like I said this is the question okay, almost every year we'll ask different chapter 1 but this year I predicted the kinetic chemistry will not be asked because asked too frequently recently. So but there is no for sure there is no for sure I don't want to say I guarantee for sure that kinetic chemistry won't come out later you say Mr. Chu said that. I don't want to hold that to responsible. Okay, any else? What chapter got most definition to memorize? Actually, memorize question, definition question not that much just simple basic definition. What is the vapor pressure? What is partial pressure? What is dynamic equilibrium? Not much of a definition if you ask me. Since new syllabus coming soon, what about your ulangan on next year? Is it new or old syllabus? Definitely they will follow the new syllabus, old syllabus Don't worry too much I still remember when we have 2012. 2012 is the last year that they do the before they go to the semester system. Students still sit for this one no problem so don't worry too much about things that not yet happened. Why don't you worry right now? Teacher, what is the difference between symmetrical, polyatomic, and asymmetrical? Oh, okay. Symmetrical and asymmetrical in here. Can I go this with you? Okay, so I close the slide. Okay, let's wait for a while. Wait, sorry, give me 1 minute. Okay, so can I scroll to this one? Okay, you have the VSEPR theory in here. Okay, okay, so you have this VSEPR theory. Okay, so these are the linear. Can I close your comment for a while? Okay, now these are the VSEPR theory that you have to know. Usually when we say that it is a symmetrical molecule, symmetrical molecules are molecules that have only bond pair electron repulsion. So definitely linear is symmetrical, trigonal planar is symmetrical, tetrahedral is symmetrical, and then linear this linear trigonal bipyramidal is also symmetrical. Trigonal bipyramidal we also consider as symmetrical, even though not really symmetrical. And then linear AB2E3 also symmetrical, and then octahedral is symmetrical, square planar is symmetrical. Okay, those other than this shape, they are in asymmetricals. Okay, so teacher, is it important to understand why is the molecule symmetrical or not? I won't say that it's very important, but it will lead you to understand whether a molecule is polar, non-polar. Because to know whether a molecule is polar or non-polar, you have to depends on this one. These are the summarized of how covalent compound is categorized based on this one. So you use this whether it's symmetrical or asymmetrical to tell whether its molecule is polar or non-polar. Okay, so everything is inside the YouTube. You can always refer to it. Okay. Okay, I hope that I answered to your questions. Okay, so I go down one by one. So okay. So can I use correction? Can. Sir, when answering questions regarding to melting point between ammonia and HCl, should we mention melting point of NH3 is higher because ammonia can form hydrogen bond while van der Waals forces, or just say NH3 form hydrogen bond? It depends on what you are comparing. NH3 and HCl are totally two different molecules. They won't ask, I don't know but so far I never see, if they are irrelevant, they won't ask you separately. Okay, definitely they have some relationship, only then they ask you. But I will straight away tells you that for ammonia, you just say that it has hold by hydrogen bond. If HCl are polar molecule hold by weak van der Waals forces. So that is what I will answer in here. Okay. Okay. Teacher, is there any recommendation to improve chapter 1, 2, and 3? I really want to have strong understanding for this topic. Isn't it a little bit too late if you want to have a strong understanding? But actually, it's quite important for you to understand, especially chapter 3. Chapter 3 is the fundamental of all chemistry for semester 1, semester 2, and semester 3. So keep on repeating, looking at the YouTube for chapter 3. Okay, I'm so sorry. That's what I can say. You just have to keep on studying the chapter 3. But at this very last moment, my advice for you is do past year question, understand the question, understand how to answer is more important. Okay. Is it a must to memorize angle for each shape? Angle not necessarily. Agak. Okay, it's more important to memorize number of bond pair, lone pair, what is the arrangement, what is the shape. That is more important. And of course, you have to know how to draw the Lewis structure. Okay. Okay, how to describe the formation of bond using sp hybrid orbital? You can refer to my YouTube on, I explain how you describe the formation of the bond using sp hybrid orbital. I explained that. I explained for a lot of molecule. If you buy my books, you can see that I explain not only for BeCl2, I explain for ethyne molecule, I explain for nitrogen, I explain for hydrogen cyanide also. Okay, so you can refer to that. Okay, so will you do live for Sem 3? Yes, I will. Don't worry. I will do live for every Sem. You follow my YouTube, you see what every year, every semester I will do one. Okay, so record tak sebab saya nak tengok balik ada dia automatically save dalam YouTube. Okay. Okay, so when comparing boiling point, it's always discussed about van der Waals forces. Not necessarily. If you look back at the question number 19 just now, okay, if you look back at the question number 19 just now, okay, this one. if you look back at the question number 19 just now, okay, so I'm going to scroll back to question number 19. Okay, so in question number 19, when you want to discuss melting point, boiling point, okay, there is this way of how you want to know when to use what, isn't it? If you want to compare metal ionic compound and covalent compound, this is the way. And then if you want to compare, let's say, covalent compound, okay? So van der Waals forces, okay, if covalent compound, then you have to see whether the molecule is polar or non-polar. Okay, can I scroll back to this? Sorry, okay. Okay, so okay, so if you want to compare between this one, the first thing that you need to, the factors that affect the strength of the weak van der Waals forces, number one is the molecular mass. Can I close down your comment for a while? Okay, the first that you need to do is have a look at the primary factor is, of course, molecular mass or molecular size. And then if they have almost the same molecular mass or molecular size, then it depends on the dipole moment for polar molecule. And then if it is a non-polar molecule, you look at the total surface area. So this is usually the way of how you compare in between them. And then if you still remember, you have this graph that you need to understand about how to explain why is it that the boiling point of this molecule goes like this, like this, like this. So all of them I already explained inside my books. So you might want to go to have a look on how do I explain them. Okay, you can go to the YouTube also to see on how I explain them. Okay. Okay. So teacher, what is different between paramagnetic, dimagnetic out of syllabus? This is not SEM 1. And nowadays even SEM 2 also paramagnetic, dimagnetic won't ask. Don't bother about all this, please. But I'll still answer to you. Paramagnetic means that if you have, as long as you have all of them are pair electron, then they are dimagnetic. If you have a single electron, then they have a paramagnetic. That's what I can say. Okay. Okay, so any else question? Because I'm about to close the live already. Okay, so I guess that is all for our live today. So I hope that you learn a lot from the live, and those who already missed my talk, you can always come back to the YouTube video. It's already recorded there, so I won't take down, don't worry. Okay. Okay, so I wish all of you good luck, and for Negeri Sembilan student, I'll see you all on this coming Thursday. Okay. So that's all for our talks today. Okay, my pleasure. Okay, see you all on this one. Okay. Okay, goodbye everybody. All the best. All the best. Good luck. 新年快乐. All right, bye.